Hello everyone, good afternoon, good morning. My name is Repakshi Nikhil Krishna and today I will be presenting my midterm assessment for Real World Analytics module. In this presentation, I will be walking you through the analysis of a Redvine dataset covering insights, transformations, model fitting and predictions. Here in this slide, we observe the scatter plots for the dataset. These plots show the relationship between different variables and their impact on the wine's quality. For instance, alcohol and pH show some patterns while the variables like citric acid, chlorides, and are less clearly correlated. Here we can see the histograms charts. From these observations, we can say that like citric acid and chlorides exhibit right skew distributions with data concentrated towards lower values. On the other hand, pH and quality are more evenly distributed, resembling a normal curve. General insights, what we can deduce is we can conclude that most wines in this dataset of average quality, variables like citric acid and chlorides tends to cluster at lower ranges, while pH is well balanced. This implies we'll need to apply transformations to address skewness and normalize the scales for better model fitting. To address these skew distributions which we have observed from the previous slides, we have applied specific transformations. For citric acid variable, a log transformations to reduce skewness. For chlorides, a square root transformations to moderate extreme values. For total sulfur dioxide variable, a power transformation to highlight moderate values. For pH variable, a reciprocal transformations to manage its inverse relationship with quality. For quality variable, a log transformation for consistent scaling. Additionally, min-max normalization was used to scale all the variables between 0 and 1, ensuring compatibility with the models. And while I execute all the models, here are the error observations I have observed. And another table also showed the correlation coefficients as well. Here we can say that with the different models used, the metrics like root mean square error, average absolute error, and correlation coefficients like Pearson and Spearman correlation, we can say that weighted arithmetic mean and power mean with p is equal to zero point 0.5 showed the lowest RMSE and average error, where the power mean p is equal to 2 had the highest Pearson and Spearman correlations, making it the best choice for capturing variable relationships. So the best fitting model and prediction is from the above observation, we could say that power mean with p is equal to 2 because of its strong correlation values. Using this model, I predicted the quality of a wine with specific inputs like citric acid as 1, chlorides as 0.75, total sulfur dioxide as 40, pH as 3.53, alcohol as 8.3. The predicted quality was approximately 1, which aligns with expectation for wines with low alcohol and high sulfur dioxide content. Conditions for higher quality wine, which I could say is to produce higher quality wine, the following conditions are ideal. Lower chlorides reduces salty flavors, optimal sulfur dioxide, balanced pH, and higher alcohol content. Implications and limitations are finally the model has some important implications like alcohol and sulfur dioxide are critical in determining wine quality. These insights can guide winemakers to improve their products, where the limitations are because we are using linear relationships. This model assumes linear relationships. We may not capture more complex interactions. Also, the results are specific to the data sets and more generalized to other examples.